I guess I have to tell that joke again since I just told it. Limiting reactants are twice as much fun as stoichiometry. There we go. Now that it's recording. All right. We're not going to get to that demo today, guys, but we'll get to the demo tomorrow. You take a look at this picture for a second. Do you remember those cookie problems that we did on that first worksheet? If you've got 4 cups of chips and you've got 1 cup of dough, how many cookies can you make? Okay, that's a limiting reactant problem. Because a limiting reactant problem has you look at your reactants, the things that you need to use to make a product, and analyze how much you can make. Okay, so if you're looking at this picture here, what does it look like they're missing the most of in order to make cookies? Yeah, it looks like that sugar canister is almost empty, right? So whoever's making cookies here with a particular set of ingredients, it looks like sugar is the limiting reactant. The reactant is going to limit how many cookies we can make. All right. In a chemical reaction, limiting reactant is going to be the one that's present in the smallest stoichiometric amount. Okay. So notice it's not the smallest amount in grams, it's the smallest amounts stoichiometry-wise. So you're going to have to do some stoichiometry to figure out which the limiting reactant actually is. And if we're looking at this picture, these pictures that we've got here, hydrogen and oxygen on the left-hand side, what does hydrogen and oxygen make when you combine it together? Check out this guy over here. Makes 2 hydrogens and an oxygen, which is called water. Okay. So if I had 10 hydrogens and 7 oxygens, I want to know how much water I can make. Okay. I'm gonna be able to make how many waters from that? We could count them up, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. We can make 10 waters from that. Do we have anything left over? What's left over? The oxygen. Okay, so there's some oxygen atoms left over. So what were we limited on? We were limited on hydrogen, right? Hydrogen's my limiting reactant. And then there's another term, excess reactants. All right. Excess reactants is a reactant that you've got plenty of or more than enough of. I'm not even going to ask you guys which one we have excess of, right? That'd be a silly question. We've got here, the other key term we got here is theoretical yield. A theoretical yield is going to be the maximum amount of product that can be made. So if you remember, we had that cookie dough recipe thing where we had a cup of dough and 4 cups of chips. It turned out we could only make 5 cookies with the amount of dough we had, but we could make a whole bunch of cookies with the chips that we had. The 5 cookies, the least amount, was the theoretical yield. In theory, we could only make 5 complete cookies with the reactants that we had. That makes sense, right, guys? Maybe. Okay. This is different from the actual yield. So in actuality, I was able to make 5 cookies. Well, in theory, I was able to make 5 cookies, right? The dog barked. My toddler grabbed my leg and I dropped the cookie on the ground. The cat scampered by and grabbed it. Now how many cookies can I actually make? 4, right? So now when I actually make cookies, I've only made 4 cookies. That's my actual yield. Okay. So, well, if I can't eat it, it's not been made, right? So, technically speaking, I made 4 cookies out of a possible 5 that in theory I was supposed to be able to make. So what percentage do I get for making cookies today? Right? I do 4/5, I multiply it by 100, and I wind up with only an 80% cookie completion rate. 4 cookies is enough for me, so that's good, right? Bad for you guys. So this is what a stoichiometry, this is what a limiting reactant problem is going to look like. Okay. You're going to have access to a balanced equation. and you're probably going to have access to know how much reactant that you start out with. From here, you've got to do a little bit of stoichiometry to find out what your yield is going to be, because they're asking for theoretical yield here. All right. So basically, we've got to set up two stoichiometry problems. Oops, there we go. And in the first stoichiometry problem, we're taking the amount of nitrogen and we're solving for the product. We get 17 grams of ammonia. In the second stoichiometry problem, we start with that 9 grams of hydrogen and we get 51 grams of ammonia. And we're going to look at that and we're going to say, which one can we theoretically make, 17 or 51? 17 is the smaller number, so that's going to be my theoretical yield. If I'm asked what the limiting reactant is, it's always associated with the theoretical yield. So nitrogen is my limiting reactant. Okay. That means that hydrogen must be excess. So I'd label hydrogen as my excess reactant, but I don't think that there's a little thingamabobber that's going to pop up here. No, it's not. It's just going to show me the questions that I might ask also. So we answered which substance is the limiting reactant. We answered what is the theoretical yield. We didn't answer the